Supervised learning. We have covered major supervised learning algorithms which are frequently used in business. There are many of them, Bayesian algorithms and all are there, but the one which are commonly used is what we have discussed till now, which is supervised learning. In machine learning, you have supervised learning and unsupervised learning. What is supervised learning? You have complete understanding of the data. You know which is the dependent variable. You know which is the independent variables. And you also know which algorithms to run. Whereas in unsupervised learning, within machine learning, within unsupervised learning, no understanding of data, dependent variable, types of independent variables, and also do not know which algorithm to implement. So unsupervised learning is where we don't have understanding of the data, we don't know which algorithm to use and which is our dependent variable or independent variable. In unsupervised learning, clustering algorithms are used and these algorithms cluster or group data. Clustering algorithms group or cluster data based on similarities. The popular algorithms, hierarchical clustering, based clustering like DB-scan. So K-means clustering, hierarchical clustering, and you have some density-based clusterings. First two are distance-based clusterings. The one more latest one is density-based clustering, which is DB-scan, which is also widely used by Google and all for large-scale data. So if you look at these are distance-based. So clustering algorithms are used when you don't know which algorithm to be implemented or when you are not sure which is your dependent variable or your independent. So let us discuss the first algorithm, K-means. K-means is an iterative algorithm, unlabeled in such a way belongs to that has similar properties. It's an iterative algorithm. Multiple iterations will be run till the point where there is no change in the cluster formation. Iterations will run till there is no change in the cluster formation or the maximum iterations have been reached. In Python, 200 is the maximum iteration. Two conditions, either maximum iterations is exhausted or reached. After 10th iteration, there is no change in cluster formation, it will stop there only. So it's an iterative algorithm that keeps on running the algorithm till there is no change in the cluster formation. Okay. Now, it is a centroid-based algorithm. Each cluster will have a centroid or midpoint. Distance is, it is a centroid-based algorithm wherein each cluster will have its own centroid. Distance will be calculated from the centroid to the observation. The objective of this algorithm, to minimize some square of distance or between data points corresponding. The objective is to minimize the distance between the data points and the corresponding cluster centroid. Value of K is an integer which represents number of clusters. I think I have to change the connector. Value of K represents number of clusters. It is decided or through or also called as scree plot. So the value of K is very important here. It is either decided through grid search or through elbow plot or scree plot. Now, an elbow plot looks like this. As you can see here, you can plot the variance on y-axis and the number of clusters on x-axis. And once you see the point at which the elbow formation happens, that will be called as elbow point. This is the best cluster. Here, cluster 3 cluster is the. So once we plot the elbow plot, on y-axis is variance. On x-axis is number of clusters. It is elbow plot, not scree plot. The scree plot is for factor. Elbow plot, y-axis is x-axis number. Elbow plot has y-axis as variance or error. X-axis is the cluster number. So elbow plot is the best plot which is used for finding the exact number of clusters. Now the distance matrix So these are the common distance metrics which are used. Euclidean is default. Euclidean is default. Average distance is also there. Weighted Euclidean, chord, Mahalanobis, mean character difference, index of association, Canberra, coefficient of divergence, correlation coefficient. So these are the ones, but popularly used in K-means are Euclidean. So we have distance metrics which are there. Now, one of the common interview question is, what is the difference between K-means and KNN? Both adopt distance calculations, both do similarity-based classifications. So what is the difference between K-means and KNN? For KNN, dependent variable is compulsory. For K nearest neighbors, dependent variable is compulsory. For K-means, we don't need dependent variable. That is supervised learning. This is unsupervised learning. You can also use K-means in supervised learning, but you cannot use KNN in unsupervised. The primary difference is KNN requires dependent variable, whereas K-means does not require a dependent. That is the primary difference. Second, KNN is only used in supervised learning. K-means can be used both in supervised as well as in unsupervised. So initially, it starts with randomly assigning some clusters. In the first iteration, some random points will be taken as the first iteration. Randomly, observations are picked as, and then the distance calculation will be done, and the centroids will be, okay, the grouping of centroids will happen. In the first iteration, randomly it picks some observations or some values as centroid, and it calculates the distance, and it reassigns the centroids. You can see here, these two are closest to this, and then it has created these as one group, this as one group, and this one group. After this, it will realign the groups. A new centroid will be calculated. For the realigned group, a new centroid will be, again, the realignment will be done based on and the new centroids again will be calculated, and the whole process will run till the point there is no change in cluster formation. Like here, there is no change in cluster formation, it will run. So if you are looking at the algorithm part, initially it picks a, first specify the number of clusters, randomly initialize K centroids, repeat, assign each point to its closest centroid, maximize, compute the new centroid of each cluster until the centroid's positions does not. So you have to initially specify a K value, then the centroid initialization will start. Once the centroid initialization starts, it will calculate the distance between the centroid and the observations. It reworks the clusters and again computes the new centroid. This process will be run till the point where there is no change in cluster formation. WCSS, which is within, it is nothing but variance optimal K value. Since this is a distance method, must be done standard scalar or min-max scalar or robust scalar must be used. Yeah, I've sent you the calculation sheet. Assume K is equal to 3. Iteration 1, randomly observations. So I will select 210 and 12. These are randomly selected. These are randomly selected observations as centroids. These are randomly selected centroids. We are doing iteration 1. It randomly selected 3 centroids because K is equal to 3. Because K is equal to 3, that means we need to have 3 centroids. I have randomly picked these points 210, 58, and 12 as the, and the distance method we are going to use is Euclidean distance. Now we have to calculate distance from C1, centroid 1, 2, comma, is equal to SQRT, open 2 brackets, x2 is 2 to the power of 2 plus open bracket, fix it, minus 10 to the power of 2, close bracket. Y2 is 10. X1 is also same, na? First row. Next row onwards, it will change. First row will be 0. Next, if you see, the distances will change. So if you look at this calculation, you can see here, this is x2, x1, y2, y1. So this is the formula you need to input in the first cell. Because for the first row, x2 and x1 are same. Now make it 2 decimal. Decrease decimal to 2. Decrease decimal to 2. You have this here, decrease decimal. Select the values and click on the dots below general. Decrease decimal. Now dist from, what is C2? 5, 8. Distance from cluster 2, 5, 8 is equal to SQRT, open two brackets. First select 5 to the power of 2 plus open bracket, fix it Fn minus F4, Fn plus F4 minus 10 to the power of 2 close bracket. 5 minus 2 whole square, 8 minus 10 whole square. 5 and 8 are the centroids, so you have to fix them. 5 and 8 you have to fix it by pressing Fn plus F4. So you'll get distance of 3.60, and for 5, 8 you'll get 0. Okay, and decrease the decimal to, this is the formula which you need to put in the distance from SQRT, open two brackets, 1 Fn plus F4 minus 2 to the power of 2 plus open bracket 2 Fn F4 to the power of 2. This is for the third cluster. No, we are not doing scaling it because these are already small numbers. No? When there are bigger numbers, we need to scale. These are small example and small numbers only. We'll implement scaling and when we are doing on the Python data. These are we have taken 3 centroids and we are calculating the distances from each of the centroid. Right? Now we have to assign observations to cluster. Which observation goes into which cluster? Till now, what we have done is we have randomly taken some observations as centroids, and then we calculated the distance of each observation towards the centroid. Each observation to 3 centroids. The cluster assignment would be based on the smallest distance. Among these 3, which is the smallest distance? 0, which is cluster 1. So observation 1 will go into 0 is the lowest distance, right? In this 3. So cluster 1, A1 will go into cluster 1. In these 3, which is the smallest distance? Cluster 3. So A2 will go into cluster 3. These 3, what is the smallest distance? C2. Cluster 2 is the smallest distance. These 3 again, cluster 2 is the smallest distance. This also, cluster 2 is the smallest distance. This is also cluster 2. This is cluster 3. This is cluster. So A1 will go to C1, A2 will go to C3, A2 and A7 will go to C3. Rest of all will be into C2. Split the data into clusters. So we have completed iteration 1. This is the first iteration. Now copy the data, paste it down, remove the color codings. Okay. How many observations are there in cluster 1? Only 1. So the centroid would be, there is only 1 observation in cluster 1. So that will be the centroid. Now cluster 2, how many observations are there? 1, 2, 3, 4, 5. So let us say 1, 3, 4, and 5. Now in the bottom, you will see the average. Average is how much? 6 is the average. The new centroid is distance from 2, 3, 4, and 5. Again, average is, so the new centroid is 6, 6. So select these observations, 5, 7, 6, and 4. You go on the bottom, you will see average, count, and sum. Select these 3 cells using control. Keep the control tab pressed and then select these cells. On the bottom, you will see the average. Average, sum, and count. All of you can see, use the control and select the observation. Similarly, do it for the next also. 4, control down, 8, 5, 4, and 9. Sorry, second column. So this time we are calculating centroids based on the cluster assignment. We are calculating centroids based on the cluster assignment. Similarly for C3. How many are there in C3? Average is 1.5, 5, and 2. 1.5, comma, 3. Now we will calculate the distance. SQRT, open two brackets, 2 minus 2 to the power of 2 plus 10 minus 10 to the power of 2 is equal to SQRT, open two brackets to the power of 2 plus open bracket 6 minus 10 to the power of 2 close bracket. 6 minus this. This is the formula for the second one. 6 minus 2 whole square plus 6 minus 10 whole square. 6 minus 2 whole square plus 6 minus 10 whole square is equal to SQRT, two brackets, 1.5 minus 2 to the power of 2, 3.5 to the power of 2, close bracket. Now cluster assign. So these 3, C1, first one is C1, second one is C3, third one is C2, this is also C2, this is C3, oh, the last one is C1. We have a change. There is a cluster change. In the previous, this observation was in C2. Now it has moved to, that means we have to repeat the iteration again. So after iteration 2, one observation moved from C2 to C1. There is a cluster change. So copy the data down. So we have to, this time we have 2 observations in C1. Average is 3, 10 and 9, 9.5. C2 has simultaneous 1, 2, 3, 4, 6.5. 1, 2, 3, 4. That was rejected in November, saying I have too many obligations. Same salary, same obligations are there. I don't think it will be approved again. But BT also same procedure, right? Then it will be the same thing which will happen again. I will send you the civil report. If you WhatsApp me, I will send you the civil report. You can check into it. So the new centroids for C1 would be like this. So 2 and 4. 2 and 4 average is 3. 10 and 9. The average is 9.5. For C2, these 4 are in C2. The average is 6.5. These 4 are in C2. The average is 5.25. So 6.5 and 5.25. C3, there is no change. C3, there is no change, right? Same C3s are repeating. So the centroid is 1.5 and 3.5. Centroids will change for C1 and C2. C1 because one observation is in C1. These 2 and these 2. Right? C2 has reduced. So these four will be C2. So new centroids are these. C3, no change because same thing is repeating. Now we will do the same distance calculation. 3 minus to the power of 2 plus 9.5 minus to the power of 2. SQRT, open 2 brackets, 6.5 minus to the power of 2 plus 25 minus to the power of 2. SQRT 1.5 to the power of 2 plus 3.5 10 to the power of 2. C2, C1. There is a change. One C2 has become one C1. Now, finally, we have to check whether this will remain same or will this also change. This from, so we have C1s to 3.67. Best from cluster 2, 7 and 6. Then 4, 4.33. Best from C2 same. C3 is same. 1.5, comma 3. SQRT open 2 brackets 3.67 minus 2 to the power of 2 plus 9 minus 10 to the power of 2 is equal to SQRT open 2 brackets 7 minus to the power of 2 plus 4.33 minus to the power of 2. 1.5 minus to the power of 2 plus 3.5 C1. No change. This time there is no change. Yes, ma'am. Tell me. See, the report format was given to you. Introduction, scope of work, objectives, and all. You have to give the midterm report in that format. Yeah, what you have submitted may be your final report, but not the midterm report. You can submit it as a part of your final report. So, midterm report, you have to tell what you have done. Not you don't need to give the outputs and all. It has to be in the format of a report, but they have sent me a Jupyter notebook. Okay. So I checked with them. It says it has to be a report format, wherein it has to be in Word document converted to PDF file. I didn't get the PDF in that. I checked in the Viva project portal. There you have directly uploaded the Jupyter notebook. No, they just remove that and put the PDF only because it has to. What you have submitted may be part of your final report. But this is midterm report, right? So it has to have that what we have done till now, what introduction you have explained. That you have to put it in a report format, convert it to PDF and upload it. Yeah. No, but it will, for me it is showing only the Jupyter notebook. Yeah, delete the Jupyter notebook and upload the PDF file. Okay. If there is no change in iterations, cluster assignment, but I'm not sure I didn't get it properly. So what the Wilk guys told me was it has to be a Word document in PDF with all the report. There has to be a table also. What parts of the project you have completed and all. Just send me an email. Email it to me. The report which you have done. So this is the calculation methodology behind K-means clustering. Very simple but very effective. Works on very large scale data. Even today it is used by Google, Facebook, and other social media firms to group images, to group topics, to group what you call updates and all. So this is a very, very powerful algorithm. So it's a very simplistic algorithm, but has a lot of utility. Market segmentations, customer segmentations, we use k-means. Even in HR, employee segmentation, high performing, medium performing, low performing employees, you can create them using k-means clustering. It will create the centroids and then it will give you the groupings. So it's a very highly used algorithm for both supervised and unsupervised data. Yeah, only numerical data. If there are categorical data, then hierarchical clustering, the one which we will talk tomorrow, will be used. Which one? Deep learning. Deep learnings are different. So deep learning is a different science. The fundamental of deep learning is neural networks. So we have to study first neural network. What is a neural network? We'll calculate what mathematics is involved in there. And then we'll go into the deep learning algorithms. Now, deep learning algorithms are also predefined algorithms, like convolution neural networks for images, long short-term memory networks for time series data, IoT data. Like that, we have predefined algorithms. The ones which you can run on our normal machines, we'll implement them. But most of the deep learning algorithms, you cannot run them on systems. They require large-scale computing. So basic versions you can run on using Google Colab, not your system. We will use Google Colab to run them. But before that, we have to study neural networks. The one algorithm which is left is neural networks, which is used as both machine learning and advanced neural networks is used as deep learning. If neural network has only 3 layers, machine learning algorithm. It has hundreds of layers, it becomes a deep learning algorithm. So that is the difference. So machine learning will work on neural networks and we will also do it. So neural networks and deep learning, we will do it later. Okay. This is grouping algorithm, similar to classification, but in classification, you classify into, here it is grouping based on similarities. Cluster is a what you call group of observations that have similar. Now classification is like a boundary will be there, either this side or that side will fall. Now they may not have similar properties. They might have wide range of, but when you put an observation in a cluster, all the observations in that particular cluster will have similar. The range of deviation is high for classification, whereas it is very close in clusters. Okay, so 11:15 we'll take a break and then we'll come back. Okay, and then we'll implement it in Python. Import the data mall customers. All right, all of you imported the data. So this is data of customers that are coming into the mall. Customer ID, gender, age, annual income, and spending score. Mall data is equal to pd dot get underscore dummies. Mall data, comma, columns is equal to square bracket single quote G capital gender. sklearn